All right, so today we're going to be talking about using trig or modeling with trig functions. So you're going to be dealing with some more real life problems, a couple like that. You're also going to be trying to look at graphs and then write functions given those graphs. Okay, we're also introducing two new terms to you, frequency and sinusoid. Sinusoid is just a cool term to say. You want your friends to call you by a cool name other than your name, which is obviously cool. You can say, you can also call me sinusoid for short. Okay? All right. Frequency. Frequency, when you hear that term and you're dealing with these trig functions, the frequency is just the reciprocal of your period. Okay? Frequency is the reciprocal of the period. Okay, mathematically, we can write that as f is equal to 1 over p. All right, 1 over p, remember that means 1 over whatever is the reciprocal of it. Sinusoid. Sinusoids are graphs of sine and cosine functions. Just a few vocab terms, and then there's a lot of places for you to write notes. Look at all that blank space, just for later, just for fun. Okay? Okay, so you guys are working on page 270, number 1, an alternating current generator, which means AC generator, converts motion to electricity by generating a sinusoidal, generating sinusoidal voltage. It's just like a cool term, man. Yeah. Say it like 10 times. I mean, you got to say both words. Generating sinusoidal. It's awesome. Great tongue twister. Okay. Assuming that there is no vertical offset and phase shift. Now, let's think here as it says to write a sine model. Think back to our sine model, y equals a sine b x minus h all plus k. Now, when they go into, I mean, like you see a word problem, you're like, okay, great, fantastic, great, okay, I know that it's sinusoidal, it's a sine or a cosine curve. Assuming that there is no vertical offset and phase shift. Which one of these is a phase shift? H is your phase shift. There is none of that. We can get rid of that. There is no vertical offset, meaning it is not translating vertically, which means K, we can get rid of that. So really we are now down to this. Now we can also get rid of that. We're like, woohoo! Man, our problem is half as long. Yeah. The voltage oscillates between negative 170 volts and 170 volts, meaning it goes back and forth between them. Okay? Yeah. So when you're thinking in terms of volts here, okay, you're negative 170, you're positive 170, and we keep reading, then with a frequency of 60 hertz, write and graph a sine model that gives the voltage as a function of time. That means V is your Y and T is your X. Okay? Which means if I am fluctuating between positive 170 and negative 170, if I was to graph that, I would be fluctuating on a vertical axis from 170 to negative 170. Why vertical? Because voltage is your Y-axis. And so when I am fluctuating between here and here, I am going back and forth. Or in terms of a sine curve, I'm going up to there and then down to there. And then up to there and then down. Okay? That is a fluctuation. It's oscillating between them. Meaning my A term is, good, my amplitude is 170. Okay? Yes, this is negative. Okay? All right, so let's put a few things together here. We know that y is not y, it's actually v. We know that a is not a, it's actually 170. We know that sine is sine. Whew. Okay. We don't know b yet, and we know x is not x, it's actually t. From there, the only thing we have not used is our frequency. Now our frequency, remember, our frequency is equal to 1 over the period. Okay? And if we know one of these two variables, we can find out the other. So we know the frequency is 60. That's 1 over p. Now why would I want to know p? B is what? 2 pi over p. So if I find p, I can find b. P is, the reciprocal of this, 1/60th. Which means b is 2 pi over 160. Or 2 pi times the reciprocal of that, 60, is 120 pi. So BB, 120 pi. So we'll get rid of the b here now. We will call it 120 pi t. Do not forget your independent variable here, your x, your t, your whatever. I did that all of third period. I had to keep going back and fixing it. I'd write a nonsensical equation because I didn't have a variable in there. I guess I just wrote a bunch of linear stuff. Okay. All right, good? Neato. Questions? Okay, very good. Let's take a look at number 2. Write a function for the sinusoid. There it is. Sinusoid. Yeah. It's awesome. Okay? Write the equation for the graph. Yes. Alrighty-o. Have your attention up here. So if it's a sinusoid, we're going to go sine or cosine, obviously. Okay? It looks like a sine graph. How many of you use sine? How many use cosine? Okay, no one uses cosine. Now, there are multiple ways you can come up with these functions. Okay? First, if you're going to use sine, or cosine for that matter, you need to know A, you need to know B, and if there's an X, or excuse me, a horizontal shift or a vertical shift, you need to know that. Now, in this one, when you look here, that's the beginning of a sine curve, and it actually doesn't have any horizontal shift, or it doesn't have to. I guess if you want to say it shifts 180 degrees, that'd be kind of silly, but anyway. Okay? No sine or no horizontal shift. Okay, so we start here. Our amplitude runs here to here. Half of that is 2, so our A term is 2. Some could argue that it would be negative 2, but if it's negative 2, then you have to do other stuff to it. Okay, so what I'm trying to say is you could have multiple different functions here. Yeah, really. Some are much easier to deal with and more direct than others, but you're going to see that more so on the next problem than this one. But this one, most of us come up with the same thing, at least that much of it. How many got at least 2 sine? Okay. What be your B term? Okay, how many got 4? How many got pi over, someone said something else. Pi over what? No? Okay, what else? 2? How many got 2? Okay? B. What is the period? Yeah, what is that? Hey, remember when we started graphing these? 0, max, 0, min, 0. Right? All of these things, they were broken up equally. Remember we went one line per spot? start at 0, and then our max. Now that was exactly halfway between that 0 and that 0. This is pi over 6, which means my interval is pi over 6. That's 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, which is 2 pi over 3, which no one had. Right? No one had it? Oh, we had it. We just didn't want to say it. Right? Okay, 2 pi over 3. Did I put that in the right spot? That's the period. That's not correct there. That's B. We need to put B in there. The period is 2 pi over 3, which means B is 2 pi over 3, which is 3. That be the right B. Okay. Questions? How many of you struggled figuring out what this coordinate was right here? Okay, that would be where I anticipate you struggling. You got to remember that if you can figure out what your first maximum value is, as long as you're starting at a 0 on a sine curve, that first max is what your theta value for that first max, or your x value for that first max, is what your interval is going to be, what you're going up by. It's a key thing to maybe write into your notes so you remember that. Jackson, you just waving? Fantastic. Okay, we'll come back. We'll get there. Yeah, that's ridiculous. Are you saying this should be positive? Way to be positive. Jackson's a pretty positive guy too. So. Okay. All right. Now let's move on to number 3. Jackson, I just saw you waving at us. Yeah. Nice. Yeah. Seriously. Legit. Some of you just can't do that, so you're quite jealous. Use your Spock handle. All right. Number 3. Give it a go. All right. How many are using the sine function this time? How many are using cosine? Yes, I'd use cosine as well. Okay. How many of you have an amplitude down? What is the amplitude? AMP equals? No, an amplitude is never negative. Amplitude is 1/2. You could say A is negative. If you want to say A is negative, that's okay, but the amplitude is positive. So how many of you use negative amplitude? No, you can't. How many use negative A? Okay, how many use the positive A? Okay, some of you aren't like even voting. How many use an A term? How many use positive A? How many use negative A? Okay, I'm going to go with the negative A to begin with, and then I will go to positive. So all you with positive A, do not erase your answers because you're like, I did it wrong. You didn't necessarily do it wrong. Okay? So you start here. If that's the case, you are then traveling one complete cycle, a period length, right here. So P is 2, which means B is 2 pi over 2, or pi. Don't forget x. How many got that? Good. That is correctamundo. Now, there are other answers you could have. How many used a positive A term? So use 0.5. Now, if that's the case, your B term still does not change. However, you would have then a horizontal shift. Meaning, your coordinate would move from here, it would have started here and moved to there. That would be x minus 1. Anyone get a different one than that? I did. X plus 1 too? Like 12?
No, like also.
Oh, okay. X plus 1 also? So the question is, will that one work? Which means you had a point right here that moved from here and went that way. Is that true? Yes, you could. And as I think Riley said, you could do sine and move it a half a point, right? So no one actually used sine because we all thought cosine was much cooler. Okay, but if you use sine, you'd have pi, and you would have this point right here would have to move back, or that one there. So x plus or minus 1/2. Okay? Well, actually, I'm sorry, with sine, you'd be here, so it'd be x minus 1/2. Otherwise, it'd have to be negative sine if you moved it plus 1/2. Okay? Hey, all of those would work. Now, for those of you that are stressed right now because you're like, I like math because like there's one answer, and that's not one answer. If that's you, and just so you know, there's an infinite number of answers here. That would work, right? Because you just could keep shifting it. Okay, so for those of you that stresses you out, just pick the most direct answer, which probably would be this one right here. Okay? Yeah, the shortest one. All right. Questions? No stressing. I would. Yeah. Okay. Number 4. No, the more you write, hey, you guys, good point. The question was, on the test, will you accept all of those? Yeah, I would accept any of those. Just keep in mind, the more you write on a test, the higher the probability that you will make a mistake. It does not mean don't write a complete answer. Obviously, write a complete answer. But if you continually expand, like what I'm saying is, if you say, I'm going to show off how smart I am, and you write all of these answers, and you mess up right here, maybe you put 3 4s, then you just missed a chunk of the problem. Yeah, because you messed up. You made a mistake. Hey, if you build 4 planes and 1 is bad, right? That's a bad deal. Well, and if you're the one on the 4th plane, you're going to be upset. Okay? I agree. If it's a bad answer, don't put it. All right, let's move on. Hey, number 4. Oh, my goodness. All right, move on. Number 4. Okay. Hey, I am going to start by drawing my midline. So last week we referenced the word midline. Okay, and I said, well, when we do shifts and stuff later, I'll talk more about that. This is where a midline might help you out a bit more. So really, that's like taking your original XY axis here and just sliding it upward or downward. Okay, so here's my midline, meaning to help me find the amplitude, I am figuring out the distance I'm going up above or below the midline, which in this case is 2. So the amp is 2, meaning my A term has to be positive or negative 2. It's up to you which one you use. All right? So if I just pretend for a minute that this is my x-axis or my theta axis, I guess in this problem it's x, okay, and I'm going down from here, I could use negative cosine, right? Or excuse me, negative sine. Okay, so I could say y is equal to negative 2 sine that would say I'm starting here and I'm going down. And then I end right here, which is at 4. Okay, so that means a period length is 4. So B is 2 pi over 4, or pi over 2. So we get pi over 2. I don't have a phase shift in this situation. I'm not going horizontally. However, I do have a vertical shift, a vertical translation up 3. Okay, I did forget the x. You've got to be kidding me. Even after I said don't forget it. Okay? If you or someone, is anyone else forgetting the variable x or t in there? Okay, well, then I feel bad. If someone else was, I'd feel a little better. Oh, thank you. Oh. If you did so here you would have, if you did positive, you did cosine? Okay. Who else used cosine? Okay, well, let's do cosine then. So this one will work. Let's go cosine. You're still going to have the same A. Well, same amplitude. You're still going to have the same B term. But if you're using cosine, then this piece is you're going to have a phase shift, right? So did you use positive or negative 2? Okay, so if you use positive 2, then this point right here, or this point right here, has to get to there. Thanks. Okay, so if I'm moving this from here, so it's shifting this way, that would be minus 3. So x minus 3, all plus 3. Or you could have said, if you move from here to there, that would be x plus 1, I think, isn't it? X plus 1. Okay, so any of these would work. Okay. You guys starting to get these? Yeah. All right. I don't want you to do the next one. I don't want you to write anything down. I want you to look at it, and this is not a good strategy in doing math. But look at it and tell your neighbor what the answer is.
Let me see just a second.
Okay, time's up. Is it sine or cosine?
Cosine.
Cosine. Amplitude is?
3.
3. And what's the period?
1.
2 pi, which B is 1. Okay. I got it. How many got it? Good. Okay. Now I did the easy one like that just so you guys could try number 6. That one's fun. Give number 6 a go. All right, let's start. Ethan's back, we can start. Okay. The pedal of a bicycle wheel is 7 inches long. Nice. The lowest point of the pedal is 4 inches above the ground. Okay, so I got to start drawing my picture. Here is my pedal. Impressive, I know. Okay?
Yes.
The pedal of my bicycle is 4 inches above ground. We're going to just assume everything's in inches since it says that. Okay? The pedal of the bicycle wheel is 7 inches long. The lowest point is 4 inches above ground, so we can now get rid of all of that. A cyclist pedals 3 revolutions per second. Write a model for the height in inches of the pedal as a function of time in seconds. In other words, h is your y, t is your x. Given that the pedal is at its lowest point at t or when t equals 0. So in other words, it starts at its lowest point. So you start pedaling, and as you start pedaling, you are, if you've ever ridden a bike, if you haven't ridden a bike, we don't have much context here, but you're going around in a circle. Okay? I know. Now, as you go around in a circle, you are creating a periodic function that would start, stay with me here, it would start right there, and it would move upward and downward, like so. Meaning this is a negative cosine curve. Now, from ground level, stay with me, from ground level up to here, we have traveled how far? 11. That means my function, which is in terms of h, so we have h of t is equal to negative, is it negative 11? It's negative 7, right? That's negative 7. Okay, or I shouldn't put negative 7 there. That negative 7, okay? That's half of our total amplitude, which is 14, right? The pedal, if we sweep it out, has a diameter of 14. Okay? Negative 7 cosine. Yeah. Okay? Hey, say with me. What's B? It's 3 revolutions per second. Time is being measured in seconds. So right here, I make 3 revolutions. Right? So there's 1. There's 2. And here is 3. I'm kind of interrupting my function here, but okay. This is 1 second. What's this? No, this is 1 second. This is 1/3 of a second. So the period P equals 1/3, which means B is 2 pi over 1/3, or 6 pi. 6 pi x, we don't have to do a phase shift. However, did we do a vertical translation? Yes, the vertical translation was, here's ground level. That means this, like if we're thinking theta axis, that's this level. It's actually 11. That's where that 11 comes in. So really our ground level, our actual theta axis or x-axis is right here. All we have up here is our midline. Yes, it should be t instead of x. Good call. At least I remembered a variable. But yes, good. Pretty cool, huh? Oh yeah, you don't have to tell me. Hey, if you want to see how well you understand that, you can try 7 tonight. Okay? All right. Here you go. Number 8. What I need you to do, number 8 on your assignment tonight, this is on the practice A side, says the table shows the depth D in feet of water at the end of an inland dock that is located in a saltwater river that is affected by ocean tides. The time is measured in hours with T equaling 0, representing midnight. Josh? Okay? All right. Use sinusoidal regression to find a model that gives D as a function of T. sit down. Golly. You guys will be the same people that don't know how to do this later. Sinusoidal regression. Now it says, pay attention. T equals 0 at midnight, meaning this is 0. This is 2. This is? All right. Hey, you guys, remember how to use a regression. You have to go to your stat menu. And then you go to edit. And then you enter your list. Now, I already entered these earlier today, so I'm well ahead of the game. Yeah, thank you. Okay. Stat. Edit. Enter your lists. List 1 is my time. List 2 is my D. Okay. Okay. Hey, looking up here. Once you get done with that, we hit quit. We go to stat, calculate, and we are calculating the sin regress. Sin regress. S. So letter C. Okay, notice you have to have list 1 and list 2. Okay, and hit calculate. And it gives you a form here. A sine, parenthesis, bx plus c, all plus d. And then they tell you what A, B, C, and D are. Okay? We're going to go ahead and round to the nearest tenth on this. Okay? So if I'm writing it out, y equals, really hard to see that. Okay, y equals 1.3 sine 0.5 x minus 0.4 plus 3.1. Thank you. All right. Now, we should actually change these because they're saying d as a function of t. And then they ask the question, or ask you to predict the depth of the water at 5 p.m. What time is that in terms of our measuring here? Yeah.
Would that be 17?
It would be 17. So when t equals 17. So one way to do that is actually plug 17 in for t. The other way to do it is to go to your y equals menu and enter that equation. Anyone remember? Bars down to option 5, statistics, equation, and regression equation. Yeah. And then go to your table. Okay. And at your table at 17, it's 4.4. 4.4 feet. Okay, once again, let me walk through the y equals again. Okay? It's bars, option 5, statistics, over to equation, EQ, and option 1. Make sure you are in radians. If you're not in radians, it's going to be bad for you. You stay in radians unless they tell you otherwise.